In this video, we want to solve this system of equations involving logarithms. So for the first equation, we have the log of y to base x equals to 3. The log of 4y to base x is equal to 5. So the main thing we're going to use here is the definition of a logarithm. And it looks something like this. The log of x to base b equals to some number L. That's your logarithm. If and only if, that's what this symbol here, this implies what's on the right, and what's on the right implies what's on the left. So if you have this type of equation here, you can write it as x equal to b to the L, where the base of the logarithm is always positive and never equal to 1. So when you solve a system of equations, you have to make sure that what answers you get that involve a base or the value of x, they have to satisfy these conditions. X, of course, also has to be positive. You can't take the log of a negative number or 0. It has to be a positive. So let's look at the first one then. I'm going to rewrite it. This is your logarithmic form. We're going to write it in the exponential form. So that means equation 1 can be written as y is equal to whatever this is right here, whatever you're taking the log of, that should equal to whatever the base is, in this case x to the third power. So this number has to equal to this base taken to that power. So it means y equals to x to the third. In the same way, what are we taking the log of? 4y. So 4y should equal to whatever the base is, it's x, taken to the fifth power. And remember, it's understood here by the definition, x has to be positive, can't take the log of a negative number. And of course, y would have to be positive here also, because then this would be negative here. And then you can use any method you want here. So let's use a substitution here. Y is equal to x to the third, so let's plug x to the third into the second equation. So this will be 4, and then instead of the y, I'm going to put x to the third. Should equal to x to the fifth. So making that substitution, now I have a single equation with one variable, in this case x. So by doing the substitution, I've eliminated the value of y, or the variable y. So let's take this over to the other side. This will be x to the fifth. This comes over, so makes it a negative, minus 4x to the third. And then I'm solving a fifth degree equation here. Let's bring it over here then. And I'm going to factor in x to the third here on on the right side. So this would give me then x squared left over there and a minus 4. So now we have the product of factors, and that product is equal to 0. Either one factor has to be 0, the other has to be 0, or they both. So we said both factors equal to 0, so x to the third has to be 0, or x squared minus 4 has to equal to 0. X to the third is equal to 0. There's only one value the x can be there, and that's x to the 0, or x equal to 0. So only one value x can be here for x to the third equal to 0. That's x has to be 0. But remember we said x here is a base, cannot equal to 0. So this one we have to reject. X cannot be 0. That's not going to be a solution. And then over here then, I have x squared minus 4 equals 0, so I'm going to factor that into x minus 2. X squared minus 4 factors into x minus 2, and x minus 2 and x plus 2. So this would tell me then that setting each factor equal to 0 here, x minus 2 is 0 when x is 2, and x plus 2 is equal to 0 when x is negative 2. But again, x represents a base, and the base cannot be negative, and it cannot be 0. So this one you have to reject. So the only possibility that I have then is that x is equal to 2. So if x is equal to 2, what is y? Now we just need the value of y. So put a 2 here where the x is on this first equation here. 2 to the third is 8. So y is equal to 8. So that's your solution. Sometimes we write it as an ordered pair since we have a system of equations. So we've got 2, 8. Write it as a solution set, and that's the solution for this system x can be 2, or y can be 8. Right? X is 2 and y is 8. And then you always want to check your solution. If you have time, you're taking a test and you have something like this, then you got to make sure that you solve as many problems, answer as many as you can. So let's see for this one. Let's check it out. X is 2, so for this one the base is 2. That's okay. Positive, so it's okay. And then y is 8. And that's supposed to equal to 3. Does it? Well, this means, remember, that the log of 8 has to equal to, or I should say 8, if you go to exponential form, 8 should equal to 2 to the third. 2 to the third is 8, so that one checks. Now let's try the other one. Again, we have log x, we got 2, so let's put a 2 here. And then y is 8, 4 times 8 is 32, and that's supposed to equal to 5. So log of 32 to base 2 equal to 5. Is that true? Let's rewrite it in exponential form. If you can't tell, 32 is supposed to equal to 2 to the 5th. 5 factors of 2, does give you 32. So it checks. That's the solution. Thanks for watching. We'll see you next time.